Solve this equation. We have not one, not two, but three algebraic fractions. So it's going to be a good time for us. Thankfully, this one's not too bad once you know a few strategies and common steps. So the first step with this one is we want to combine the fractions on the left-hand side into a single fraction. So to do that, we can cross multiply. So that's where we multiply the numerator of the first fraction with the denominator of the second, then the numerator of the second fraction with the denominator of the first, and then our new denominator is the product of the denominators. So how does that look for this one? That will be 2 times x plus 1. Then we subtract. So if this was a plus sign there, we'd be adding, but here it's minus, so we'll subtract 2 times x minus 3. And that is all over our new denominator of x minus 3 times x plus 1. X minus 3 times x plus 1. And the right-hand side stays the same. Okay, this doesn't actually look any simpler, but it will in the next 2 steps, I promise. So on the left-hand side, we can expand and group like terms in the numerator and the denominator. So let's do that. So 2 times x plus 2 times 1 minus 2 times x minus 2 times minus 3 plus 6, all divided by, now we can FOIL the denominator, so x times x gives x squared, x times plus 1 gives plus 1x, or plus x, minus 3 times x, and minus 3 times 1. And that all equals 3 over x plus 5. Now on the left-hand side again, we can group like terms. So 2x minus 2x, 0, quick maths. 2 plus 6 gives 8, all over x squared. Now we have plus x minus 3x, that gives us minus 2x. And then we have minus 3 equals the right-hand side. Okay, this is looking a lot better. In this case here, so we have an equation. We have one fraction on the left and one fraction on the right. So what we can do is sort of a variation of cross-multiplying, but instead of to combine fractions, we actually use it to eliminate the fractions. So that's where we multiply both sides of the equation by both of the denominators. So it'll simplify to 8 times x plus 5 and 3 times this x squared minus 2x minus 3. Is by multiplying both denominators on both sides, we eliminate the denominators. So we get 8 times x plus 5 equals 3 times x squared minus 2x minus 3. And just to actually illustrate this point, in case the explanation was horrible, which I think it was, let me just, so you can see what's happening here. Oh, there we go. 2x minus 3. And x plus 5. Okay, here we go. So what I meant by that, the step here, is we multiplied both sides, because it's an equation. Whatever we do to one side, we have to do to both sides. So we multiplied both sides by x plus 5. We also multiplied both sides by x squared minus 2x minus 3. Again, equation, so we have to do it on both sides. And now we see that on the left-hand side, those x squared minus 2x minus 3's cancel. On the right-hand side, the x plus 5's cancel, right? Because something divided by itself is just 1, so we don't need to write that. And what we're left with on the left-hand side is 8 times x plus 5, and on the right-hand side, 3 times x squared minus 2x minus 3. So that's what I mean when we multiply both sides by both denominators. We're essentially eliminating the fractions, and we're left with this equation. Okay, from here we can expand in group-like terms again. So we have 8x plus 40 equals 3x squared minus 6x minus 9. We can now, well, looking at this, we have a quadratic. You might be thinking, all right, let's factorize. I know how to do that. No, well, hopefully you do, but no, let's not factorize yet. We need to get it into standard form. Standard form is where we have something like our quadratic is equal to 0. Right now, it's equal to 8x plus 40. So let's subtract 8x and subtract 40 from both sides. So 8x plus 40. If we subtract 8x and 40, on the left-hand side, we get 0. I'll just write that in here. On the right-hand side, minus 6x, so we subtracted 8x, and then minus 9, we also subtracted 40. And that simplifies to 3x squared minus 14x minus 49. Wonderful. So this is where you want to be. We have a quadratic equation in standard form. So now we can factorize it and then solve for x. So factorizing, need our two sets of brackets. Looking at the coefficient of x squared, it is 3. So we're going to need one of our x terms to be 3x in order for this to expand out to give 3x squared. Because remember, expanding is the opposite of factorizing. The two numbers we pick must multiply to negative 49. So I could think of 7 and negative 7. Okay, but which one will be positive 7 and which one will be negative 7? Well, you kind of just need to try it. So if this was negative 7 and this is positive 7, to check that it works, we expand it out. And if we expand it out and it goes back to this, it means we factorized correctly. So just looking at this, I see we'll get a 21x minus a 7x, which would be positive 14x, but we're looking for negative 14x. So actually, we need this to be positive. Delete. Thank you. And this to be negative. All right, and you can check that by expanding it out, and you'll get back to this starred equation. Okay, we actually still haven't answered the question. I know it's been a while since we started at the question, but it asked us to solve. So now, to solve this, either 3x plus 7 equals 0, or x minus 7 equals 0. So 3x equals negative 7, subtracted 7 off both sides, and now divide both sides by 3. So x could be negative 7 over 3, or add 7 to both sides, x equals positive 7. Okay, well done. Pat on the back. You can have a nap now.